what if the reason you are like absolutely exhausted has basically nothing to do with how many hours you slept last night?
Right, and everything to do with um, this microscopic rust building up inside your cell.
Yeah, exactly. Because, usually when we talk about being exhausted, there's this expectation of a really simple, clean
Oh,
fix.
for sure.
It's like a low battery on your phone. You just plug it in, drink a cup of coffee, finally get a solid 8 hours of sleep, and boom, that little battery icon turns green. You're back to 100%.
Right, it's this very binary uh, input-output equation we've all been taught for decades, just rest equals energy.
Right. And it's a comforting thought. We really like the math to be that simple. But I mean, let's be honest. You eventually hit a point where you are sleeping, you are resting, you're doing all the quote unquote right things, but you still feel like you're running on fumes.
Yeah, the deep, unshakable fatigue.
Exactly. If you've been feeling constantly tired or brain foggy, inflamed, or I don't know, like you're somehow aging faster than you should be, suddenly that simple battery metaphor is just completely broken. You're looking at an energy crisis that is incredibly murky.
It really is. It is the absolute definition of diagnostic muddy waters.
Hmm.
Because, the problem isn't the battery itself. It's the microscopic engines powering the whole biological grid.
Wow. Yeah.
And if those engines are fundamentally compromised, I mean, no amount of sleep is going to magically turn that battery icon green.
Which brings us to the mission of today's deep dive. We are going to explore the specific cellular reasons behind that chronic fatigue. We've got a fantastic source today, insights from a video by Dr. Ashley Froese. She's a board-certified medical doctor.
And she does a great job breaking this down.
She really does. She breaks down the 13 lifestyle, dietary, and medical factors that are just quietly destroying our cellular energy. And the goal here is to really understand the actual why at the cellular level. Because once you see what's physically happening inside your body, you might be surprised at how much control you actually have to fix it.
What's fascinating here is that modern medicine often treats symptoms without ever looking at the power source. We are talking about mitochondria,
The powerhouses.
the literal powerhouses of your cells, exactly.
Yeah.
When these tiny cellular engines are damaged, the entire body's energy grid suffers. Your brain, your heart, your muscles, they all completely rely on this infrastructure. But establishing a baseline understanding of how we are inadvertently damaging them, well, that's the very first step to fixing the grid.
Okay, let's unpack this. We're going to start with the daily rhythm, so how we actually spend and recover energy through our lifestyle choices. Because before we even get to what we eat or like what medications we take, our daily actions really dictate our energy capacity.
They lay the entire foundation.
Right. So Dr. Froese points out that our modern lifestyle is fundamentally at odds with cellular health, starting with chronic stress. Now, we all know cortisol is the stress hormone, but I just loved her analogy for what it actually does to the cell.
Yes, cortisol gets a bad reputation, but, it's fundamentally a survival tool.
Right.
Its primary job in a stress response is to tell your mitochondria, hey, we need energy right now, make more, drop absolutely everything else. It forces them into this maximum output mode so you can deal with an immediate threat.
Right, which is fantastic in the short term if you're, I don't know, running from a bear or slamming on the brakes to dodge traffic.
Exactly.
But Dr. Froese compares constant, everyday chronic stress to having kids home all day. They're just leaving toys and crumbs everywhere in every room constantly.
So true.
Anyone who has tried to work from home with a toddler knows exactly what this does to your sanity, let alone your cells. If you're always in max output mode, there is literally never any time to clean the house.
It's the perfect visual. You are constantly burning fuel to deal with your overflowing inbox, the traffic, the news cycle, and you are creating these toxic metabolic byproducts.
The crumbs.
The crumbs, exactly.
Huh.
But because the stress signal never turns off, you never give the cells a chance to sweep them up, the trash just piles up. And that leads perfectly into the other side of the coin, which is bad sleep.
Oh, right.
Because when you're awake, even without chronic stress, you run your mitochondria hard. You build up all that oxidative junk.
So sleep has to be the cleanup crew in this scenario.
Exactly. But it's not just about closing your eyes for 8 hours. It has to be deep sleep.
Okay.
That deep sleep phase is the necessary flip of the switch. It's really the only time your cells finally go into full detox mode. They repair themselves, and remarkably, they literally fuse damaged mitochondria back together to share resources and rebuild strong engines.
Oh, wow. So they combine.
Yeah, Dr. Froese actually compared it to buddy taping a broken toe so you can walk on it the next day.
She did admit it was a weird reference, but it honestly makes perfect sense. I mean, if one mitochondrion is broken, it physically links up with a healthy one to stabilize. But if you are like doom scrolling until midnight and skipping that deep sleep phase, you are literally short-circuiting the repair process.
You're walking on the broken toe without the tape, day after day.
Ouch. Yeah, just think about your own sleep hygiene for a second. How often are we actually letting ourselves tape up those broken toes?
For most people, very rarely.
Hmm.
And that accumulation of cellular damage, well, that is exactly what you feel as brain fog and deep fatigue the next morning. It's not just a lack of sleep, it's a lack of structural repair.
Which brings us to another massive lifestyle factor, which is how we physically move our bodies, or I guess more accurately, how we don't move them.
Right, the sedentary trap.
Yeah, we have these two extremes in modern culture, the completely sedentary lifestyle and then the hardcore overtraining lifestyle. And somehow, both of them manage to wreck our cellular engines. Let's look at sitting all day first. Dr. Furs points out that sitting at a desk doesn't just make your muscles soft, it shuts down the very signal to make new mitochondria.
Because movement is biological communication.
Okay.
When you exercise, you send a demand signal to your body that basically says, hey, we're moving, we need more energy, build the infrastructure for it. But if you sit at a desk for 9 hours and then move straight to a couch for 4 more, that signal just never fires.
It's like shutting down half the generators on a city's energy grid just because nobody happens to be turning on their lights in those neighborhoods at that exact moment.
Exactly.
The city eventually loses the capacity to generate that power at all. But what's wild is that the flip side overtraining is just as bad.
It really is. The whole mentality of, if a little is good, a lot must be better, is incredibly destructive to cellular biology.
You know, thinking about this, it sounds exactly like how we treat our smartphone batteries.
Oh, how so?
Well, if you leave your phone plugged in at 100% and just let it sit on your nightstand all day, eventually that ruins the battery's total lifespan. It gets lazy, the chemical capacity degrades, and it just holds less of a charge over time.
Right.
But if you aggressively drain that same battery down to 0% day after day, constantly pushing it to its absolute limit, you're also going to completely destroy its maximum capacity.
That is a highly accurate way to look at it. Because when you overtrain, when you're doing high-intensity workouts day after day without adequate recovery, you are redlining the biological engine.
Just pushing it way too hard.
Exactly. You create a massive amount of what we call reactive oxygen species. That's just a fancy biological term for those toxic cellular crumbs we talked about earlier. You're shredding the biological wires and overheating the system.
And without the recovery, the house never gets cleaned.
Precisely. Mitochondria require a strict biological rhythm. They need the stress of movement to signal growth, yes, but then they desperately need rest, repair, and recovery. It cannot be constant chaos, and it cannot be constant stagnation.
Okay, so let's say your daily rhythm is flawless. You're just a beacon of health. You sleep deeply, you manage your stress like a Zen monk, and you exercise just the right amount to send that growth signal. Even if all of that is perfect, you can still completely destroy your engines if you put the wrong fuel in the tank.
The diet piece of the puzzle.
Yes, the dietary saboteurs. Here's where it gets really interesting. We all know donuts and processed foods aren't exactly health food, but Dr. Froese explained what actually happens inside the cell when your blood sugar spikes, and honestly, it completely changed how I view sugar.
It's a very mechanical problem at that level.
It is. Your mitochondria get absolutely slammed with fuel, but they can't burn it fast enough. It's like overloading a campfire with way too much wood. You don't get a bigger fire, you just choke out the flame and the whole room fills with smoke.
And that smoke in the cellular world translates directly to inflammation and those reactive oxygen species. The engine is literally choking on excess fuel.
Right.
Over time, that excess sugar jams up the signaling that insulin uses to balance your blood sugar. The message just stops getting through, which leads to insulin resistance, widespread inflammation, and, that stubborn inability to lose weight no matter what you do.
But it gets worse because in the modern diet, we rarely just eat sugar on its own, right? We combine that sugary treat with high amounts of polyunsaturated fatty acids. I'm talking about the modern vegetable and seed oils.
Mhm.
Soybean oil, canola oil, sunflower oil, they are absolutely everywhere.
Oh, they are ubiquitous.
Think about that quote-unquote healthy salad dressing sitting in your fridge right now, or the oil used in almost every single restaurant fryer.
Right, the omega-6 fatty acids. The main issue with these modern, highly processed oils is that they are chemically very unstable molecules.
Okay.
They react to heat and light, which makes them highly prone to oxidation.
So Dr. Froese says that combining a high blood sugar spike with these unstable omega-6 seed oils is literally like pouring an accelerant on that smoky, choked-out campfire.
It is a devastating combination for the cell. The specific mechanism at play here is called lipid peroxidation. And the easiest way to visualize lipid peroxidation is basically
By binding the
cellular
heart,
rest.
metabolism was halted.
Wow.
No aging,
This
no
combination
consumption of the
excess
body's
sugar
own
and
energy
unstable
reserves.
oils severely compromises the integrity of your cellular and mitochondrial membranes. And the membrane is the exact place where the mitochondria generate energy. If you rust the machinery, the engine seizes up.
Cellular rust. I mean, that is just a terrifying visual. So we are doing our best to avoid sugar spikes and seed oils to prevent the rust. But then Dr. Froese shifts from what we shouldn't eat to what we are desperately missing, namely protein and micronutrients.
Crucial building blocks.
Right, but I have to push back a little on the conventional wisdom here. We all hear that eating a high-protein diet is great for keeping muscle and losing fat. But how does skipping protein actually destroy energy? I always thought of carbs and fats as our fuel, and protein as just like the structural building blocks for your biceps.
Well, we connect this to the bigger picture. Protein is doing a lot more heavy lifting than just building muscle mass.
Oh, really?
Oh, absolutely. Your mitochondria specifically require certain amino acids derived from protein, things like glycine, cysteine, and carnitine. These aren't just structural building blocks. They are the active tools needed to repair enzymes and shuttle energy across what's called the electron transport chain.
Okay, the electron transport chain.
Yeah, you can think of this chain like a microscopic bucket brigade passing electrons down a line to create energy.
So without those specific amino acids from our diet, the bucket brigade just drops the buckets, the transport chain breaks down.
Exactly. The chain loses its workers. And the human body is incredibly resourceful, sometimes to its own detriment. If you aren't eating enough protein to supply those specific amino acids, your body will actually cannibalize its own muscle tissue to steal them.
Wait, really? It just eats its own muscle?
Yes, just to keep the vital cellular engines in your heart and brain running.
Wow. It prioritizes immediate cellular survival over your biceps. So a low-protein diet doesn't just cost you muscle tone, it directly starves your mitochondria of the tools they need to function.
And that same logic applies to micronutrients, right? She highlighted B vitamins, magnesium, and CoQ10.
Yes, so if amino acids are the workers in the bucket brigade, micronutrients act as the spark plugs and the physical wiring for the mitochondrial engine.
Okay, that makes sense. They are essential cofactors that keep the electrons moving down that transport chain smoothly. If you are deficient in these micronutrients, energy production literally stalls out halfway through the process. And here's the craziest part. Instead of creating ATP, which is the usable energy currency of the cell, all that potential energy literally leaks out of the mitochondria as heat.
It leaks out as heat. You're just wasting energy into the ether instead of using it to power your brain and body. I mean, that is wild.
It is a massive waste of biological potential.
All right, this brings us to a fascinating pivot in our deep dive, and honestly, there is a pretty dark irony to this next part. So our modern lifestyle and our modern diet create this cellular rust and this energy crisis. But instead of fixing the sleep, the movement, and the diet, what do we usually do? We turn to the pharmacy.
Quick fix.
Exactly. We take medications to fix the high blood sugar and the cholesterol. But ironically, sometimes the exact medical interventions we rely on to heal ourselves are the things digging the energy hole even deeper.
It's the classic medical conundrum of unintended consequences. We isolate a symptom and treat it without realizing we are throwing a giant wrench into the deeper cellular machinery.
Let's look at statins first. These are incredibly common, life-saving cholesterol-lowering medications for millions of people. But Dr. Froese points out that statins also block the biological pathway your body uses to make CoQ10.
Which, as we just established, is a critical spark plug for the cellular engine.
Right. So if you're taking a statin to lower cholesterol, but it's simultaneously blocking CoQ10, your mitochondria cannot make ATP efficiently. It completely explains why so many people on statins report deep muscle weakness and chronic fatigue as a side effect.
Their cells are basically running on half a charge because the spark plugs have been pulled.
Exactly. And then there is metformin.
Ah, metformin. Originally a staple for managing type 2 diabetes, but recently it has become the absolute darling of the anti-aging and biohacking communities.
Right. Dr. Froese mentioned she has a very love-hate relationship with it. She uses it for her patients' blood sugar all the time, but the catch is how it actively alters the mitochondria.
Yes, metformin mildly inhibits something called complex 1. You can think of complex 1 as the very first station on the ATP assembly line inside the mitochondrion. By inhibiting it, metformin is effectively lowering the speed limit at which your mitochondria can operate. You literally cannot produce energy as fast.
Which seems entirely counterproductive. I mean, if we are exhausted, why on earth would biohackers purposefully take a drug that lowers their cellular speed limit?
Well, this raises an important question about how we view cellular stress, and it gets into a concept called hormesis.
Hormesis. Okay.
The theory in the biohacking world is that by mildly blocking or blunting mitochondrial function, you induce a small amount of stress that forces the body to adapt. The hope is that this mild stress triggers new mitochondrial biogenesis, meaning the body builds brand new, stronger engines to compensate for the lowered speed limit.
But Dr. Froese noted that this is highly controversial and not actually proven to work the way people hope in healthy individuals, right?
Correct. It's a massive gamble.
Right.
You are purposefully slowing down your energy production in the hopes that your body has the raw materials and the resilience to overcompensate.
Right.
For someone already struggling with chronic fatigue, throwing a speed bump onto their energy assembly line could be a disastrous trade-off.
Yeah, that sounds incredibly risky. Okay. That brings us to antibiotics, specifically a powerful class called fluoroquinolones, things like levofloxacin or ciprofloxacin. Now, I want to spend a second here because the why behind this absolutely blew my mind.
It is fascinating biology.
Dr. Froese admitted that even she wasn't taught the cellular mechanism behind this in medical school. She just knew these drugs carried warnings for severe fatigue and tendon ruptures.
The underlying mechanism here is truly astonishing, and it traces back billions of years to evolutionary biology. To understand this, you have to know the endosymbiotic theory.
Sounds intense.
It's actually a cool concept. The prevailing scientific consensus is that our mitochondria actually used to be free-living ancient bacteria. Billions of years ago, a larger cell swallowed one of these bacteria, but instead of digesting it, they formed a symbiotic relationship.
Oh, wow.
Yeah, the bacteria provided energy, and the larger cell provided a safe home.
Which means our cellular engines are essentially ancient bacteria living inside us.
Exactly. And they still possess their own distinct bacterial DNA, completely separate from the DNA in the nucleus of our regular cells.
So when we take these powerful fluoroquinolone antibiotics, they are specifically designed to kill bacterial infections by targeting an enzyme called DNA gyrase, which destroys the bacteria's DNA.
The problem is friendly fire.
Oh, no.
Because our mitochondria share so many traits with ancient bacteria, these drugs can accidentally penetrate the walls of our mitochondria. Once inside, they mistake our mitochondrial DNA for an infection and attack it, effectively rendering the mitochondria completely inert.
That is wild.
You successfully kill the bacterial infection, but in the process, you've collateralized your own cellular power grid. That's why people can feel so profoundly, deeply fatigued for weeks or even months after taking them. Their bodies literally have to rebuild their energy infrastructure from scratch.
That is just incredible. I mean, it makes total sense when you understand the evolution behind it, but it is terrifying. And we see a similar kind of mechanical interference with SSRIs, right? The widely used class of antidepressant medication.
Yes, a very physical interference.
Dr. Froese explains that mitochondria have these tiny physical electrical generator complexes. They literally act like rotary engines, spinning around to create energy. And SSRIs can actually enter the cell and physically stick to some of these spinning complexes, basically jamming the gears.
And over time, that jammed machinery leads to a higher oxidative stress and less ATP available for the brain.
Right?
It's the biochemical reason why some people taking SSRIs report feeling emotionally flat or experiencing severe, unshakable brain fog. The raw power to the brain is literally being bottlenecked by jammed gears.
Now, I need to pause here and make something incredibly clear, really echoing Dr. Froese's strict disclaimer from the source material.
Yes, this is very important.
Some people absolutely depend on SSRIs, statins, and other medications for their very survival. You should never, ever stop taking a prescribed medication just because you're listening to this deep dive. This is an exploration of cellular biology, not medical advice. Always, always talk to your doctor before making any changes.
A crucial point. It's about understanding the biological costs and working with a medical professional to manage them, perhaps, by supplementing CoQ10 if you're on a statin, not abruptly pulling the plug on a necessary life-saving treatment.
Exactly. All right, rounding out our deep dive into modern chemical interventions. Environmental toxins. We're talking about pesticides like glyphosate on our crops, plastics like BPA in our food storage, and heavy metals like mercury. Dr. Froese says our mitochondria just do not know how to handle modern chemistry.
And the research heavily backs that up. These specific modern compounds actively block something called cytochrome oxidase, which is yet another key enzyme in the ATP assembly line.
It's like a coordinated attack.
It really is. But their damage goes beyond just blocking energy production. They actively drain the body's supply of glutathione.
Wait, if environmental toxins drain glutathione, that's a massive double whammy because glutathione is the body's main antioxidant, right? It's the cellular security guard. So you aren't just losing energy, you're actively losing the cell's main defense system against the cellular rust we talked about earlier.
Precisely. It is a catastrophic combination. Not only are these toxins halting the production of energy, but they are simultaneously disarming your cellular security system. Your cells are left wide open to oxidative damage without their primary defense mechanism to fight it off.
It's like turning off the security cameras while actively inviting robbers into the house. I mean, no wonder the cellular grid collapses.
Hey.
So what does this all mean? We've just walked through how our modern lifestyles, our highly processed diets, our life-saving medications, and our chemical environment are actively sabotaging our cellular engines. Honestly, it sounds incredibly bleak.
It can feel overwhelming for sure.
But there is a massive silver lining here. Dr. Froese emphasizes that most of this mitochondrial damage is completely reversible. By intentionally supporting your body's detox pathways, prioritizing deep sleep, and simply stopping the addition of fuel to the fire, like cutting out the sugar spikes and those unstable seed oils, you can absolutely take back control of your cellular energy.
I firmly believe that knowledge is only valuable when it is understood and applied. This isn't about living in fear of the modern world. It is about awareness and agency.
Yes, exactly.
Minimizing these 13 factors is fundamentally about returning your body to its natural biological rhythm. Your cells inherently want to produce energy. They want to repair themselves. If you can respect the rhythm of stress and recovery and remove as many chemical roadblocks as possible, your mitochondria know exactly what to do.
That is such an empowering way to look at it. Give the body the right environment, and it will do the work. But I want to leave you with one final lingering question to ponder as we wrap up this deep dive. It's something that builds on everything we've just discussed.
All right, let's hear it.
If our modern conveniences, the sedentary indoor jobs we work, the heavily processed seed oils we eat for convenience, the advanced pharmaceutical interventions we take to fix our modern ailments, and the plastics we store absolutely everything in, if all of these are the exact mechanisms starving our cells of energy, is the modern epidemic of chronic fatigue actually just a massive evolutionary mismatch?
Oh, that's a brilliant thought.
Are we essentially forcing an ancient biological engine to run on a highly toxic, entirely modern grid? Think back to that low battery icon we talked about at the very beginning. Maybe the problem isn't that you're broken. Maybe the problem is you're trying to use a charger that was never designed for your hardware in the first place. Thank you for joining us on this deep dive. We invite you to explore that thought, check your engine, and we'll catch you on the next one.